Our world is at a crossroads. We're searching for cleaner, more sustainable energy to power our future. And while options like solar and wind are fantastic, they're not the whole picture. What if we could take a fuel we already have in abundance, natural gas, and transform it into a completely clean energy source? It sounds like science fiction, but one innovative startup is making it a reality. They've developed a groundbreaking process that could revolutionize the energy industry as we know it. Today, we're going deep into the science behind this incredible technology. This isn't just an idea, it's a tangible solution that could help us achieve our global climate goals. So how exactly do you turn natural gas into clean hydrogen without releasing any carbon into the atmosphere? Stay with us as we uncover the secrets behind this game-changing innovation. To understand this breakthrough, we first need to talk about what natural gas actually is. It's primarily made of methane, which is a molecule composed of one carbon atom and 4 hydrogen atoms, CH4. For decades, the primary way to get energy from natural gas has been through combustion, which means burning it. When you burn methane, it reacts with oxygen, releasing a lot of heat energy. This is great for heating our homes and generating electricity, but there's a major downside. This reaction also produces carbon dioxide, or CO2, a potent greenhouse gas that contributes to climate change. For every molecule of methane we burn, we release a molecule of CO2 into the atmosphere. This is the fundamental problem that scientists and engineers have been trying to solve for years. How can we get the clean burning hydrogen out of methane without creating the CO2? This is where traditional hydrogen production methods come into the picture. The most common method today is called steam methane reforming, or SMR. In this process, high-temperature steam is used to react with methane. While it successfully separates the hydrogen atoms, it still produces a significant amount of CO2 as a byproduct. This is often called gray hydrogen. There's also blue hydrogen, where the CO2 produced during SMR is captured and stored underground. It's a step in the right direction, but it's expensive, complex, and raises long-term questions about the security of carbon storage. The ultimate goal has always been green hydrogen, produced by splitting water using renewable electricity. While completely clean, green hydrogen is currently very expensive and requires vast amounts of renewable energy and water, making it difficult to scale up quickly. So, the world has been stuck in a bit of an energy trilemma: affordable but polluting, cleaner but costly, or completely clean but not yet scalable. This is the challenge our featured startup decided to tackle head-on. Instead of burning methane or reacting it with steam, they use a completely different approach: methane pyrolysis. Pyrolysis is a process where you heat a material in the absence of oxygen. Without oxygen, the material can't combust. Instead, the intense heat breaks down its chemical bonds. Imagine heating a log in a sealed, oxygen-free container. Instead of turning to ash, it would break down into charcoal and various gases. This startup has applied that same principle to methane. They've designed and built a highly advanced reactor. Inside this reactor, natural gas is heated to extremely high temperatures, over 1,000 degrees Celsius, in a controlled, oxygen-free environment. At these temperatures, the bonds holding the methane molecule together become unstable and break apart. The molecule literally splits. The 4 hydrogen atoms are released as pure, clean hydrogen gas, H2. This is the fuel of the future. It can be used in fuel cells to power vehicles, generate electricity, or in industrial processes, with its only byproduct being water. But what about the carbon atom? Where does it go? This is the most brilliant part of the process. Instead of bonding with oxygen to form CO2, the single carbon atom is left behind as a solid. That's right, solid carbon. It emerges from the reactor as a fine black powder known as carbon black. This isn't a waste product. It's a valuable industrial material. Carbon black is used in manufacturing tires, plastics, inks, and coatings. It strengthens rubber, provides pigmentation, and improves the durability of countless products we use every day. By turning the carbon from natural gas into a solid, valuable commodity, this process achieves something remarkable. It's a zero-emission method for producing hydrogen. No CO2 is released into the atmosphere. The carbon is permanently locked away in a stable, solid form, a concept known as sequestration. This creates what's often called turquoise hydrogen, a new category of clean hydrogen that bridges the gap between the affordability of natural gas and the zero emissions profile of green hydrogen. The startup's reactor is powered by a portion of the clean energy it produces, making the entire cycle self-sustaining and truly carbon negative when renewable electricity is used for the initial heating. The implications of this technology are massive. First, it allows us to leverage our existing natural gas infrastructure, the pipelines and storage facilities we've spent decades building, to transport a clean energy source. This dramatically reduces the cost and time needed to transition to a hydrogen-based economy. We wouldn't need to build an entirely new system from scratch. Second, it creates two valuable products from a single input: clean hydrogen fuel and solid industrial carbon. This dual revenue stream makes the process economically attractive and competitive with traditional energy production methods. It turns a potential pollutant into a profitable resource. Third, it provides a scalable and reliable source of clean energy. Unlike some renewables that depend on weather conditions, this process can run 24/7, providing a steady supply of hydrogen to power our cities and industries. This isn't just a theory in a lab. The startup has moved beyond prototypes and is now building commercial-scale facilities. These plants are marvels of modern engineering, integrating advanced materials science, thermal dynamics, and artificial intelligence to optimize the pyrolysis process. Sensors constantly monitor temperature, pressure, and gas composition, ensuring maximum efficiency and safety. The system is designed as a closed loop, meaning nothing is wasted and no pollutants escape. It's a vision of the future of industry, clean, efficient, and intelligent. It represents a paradigm shift in how we think about our resources. Instead of a linear take-make-waste model, this technology embraces a circular economy, where every component of the input material is transformed into something of value. Looking at the bigger picture, this innovation could be a key component in a global portfolio of clean energy solutions. It's not about replacing renewables like solar and wind, but complementing them. It can provide the baseload power needed when the sun isn't shining or the wind isn't blowing. For heavy industries like steel and cement manufacturing, which are notoriously difficult to decarbonize, turquoise hydrogen offers a viable path to clean production. The journey ahead is still long. Scaling this technology to meet global energy demands will require significant investment, collaboration, and policy support. But the path is clear. Innovators like this are proving that with ingenuity and determination, we can solve our toughest energy challenges. They are turning a fossil fuel from the past into the clean fuel for our future, one molecule at a time. The transition to a sustainable world is happening now, powered by bold ideas and brilliant minds. Thank you so much for joining us on this deep dive into the future of energy. If you found this exploration inspiring, please give this video a thumbs up and hit that subscribe button. Don't forget to click the notification bell so you won't miss our next story on cutting-edge technology. What do you think about methane pyrolysis? Let us know in the comments below. We'd love to hear your thoughts. To learn more about this and other hydrogen innovations, you can visit the resource linked on screen. Thanks for watching, and we'll see you in the next video.